Hello. So this module should go this video should go pretty quick. It's the second part of the module where we're going to be talking about digital light and sound. So we're going to use a digital signal to turn on and off a sound, and we have a couple of different devices. You guys, you probably got a couple of these things mixed in with your kits, or there maybe even be with the bag that got shipped to you. You want to find the ones that are buzzers and not just elements. And there's a couple ways to do it, but probably the easiest way, if you have a 9-volt battery, and excuse me, if you don't have a 9-volt battery, just continue watching because we'll get to a point where you can just test it with code. But I like to use a 9-volt battery because they all look pretty similar. If it's a buzzer, it's going to make a noise. It's going to buzz. It's going to make a musical note or a single note just by applying power to it. So if we look at these devices, all right, if it doesn't have a sticker on it, you're going to see that there's a positive, and you're also going to see that the longer wire is positive. And on a 9-volt battery, the smaller terminal is positive. So if I touch this guy up, it's right here, it plays a tone. All right. So this is a buzzer. If I grab another one here, this one's brand new. It still has the sticker on it that's left on there, so you can solder it in place and still wash your electronics before shipping it off. Positive is going to be on this side, and once again it's got a longer wire designating positive. Touch it. Okay, and we've got a sound. This guy here is a little bit different. And it has a positive on it. It has open electronics on the bottom. And if we touch the positive to the battery on this guy, okay, there's the positive. It doesn't even have much of a longer wire. It might almost be the same size. You do have to actually look very carefully for the actual positive. It just clicks. Okay? This guy does not have any sort of electronics in it to drive it, to oscillate it, so it just goes on and off. It doesn't go on and off repetitively, so it never makes sort of a musical note. We can use these. In fact, we will use these. The beautiful thing about them is that they can actually play musical notes. They can play more than one frequency, whereas these devices that have drivers built into them, well, they can only play that note. That's the only thing they can do. All right, they really can't play any other musical notes. And apart from that, it's really hard to tell physically because some of these things have casting lines on them. Some of them are smooth, some are labeled, some are not. So you really almost have to power them up to figure out which one is which when you get them in this sort of pile with this kit. So if you don't have a battery, we're still going to figure it out. Okay? So let's figure out a great place to plug it in. We don't want to get any wiring. I don't want to get any jumpering. You could, but there's really no reason to. We have plenty of places here. This guy here, remember, is my passive. By the way, if it doesn't have a driver, it's called a passive element. And if it does have a driver, in other words, it's a buzzer, it's called an active element. So I'll take this guy here. It's active. It's buzzer. We've tested it out. And we're going to need a ground, and we're going to need some pin that we can plug it into. Well, we have a few grounds we can use. There's a ground here. You can see it labeled on the side of the board. There's a ground right there, a second pin. We can use that one. We can jumper it across a couple different ways. There's a ground here. We could use that. I'm not going to use this one. It's super convenient, but we might use that one for the passive element so we can play music. Because remember, these pins here are PWM pins, and that's going to be useful for playing a musical note. And then over here, we have another ground, and this one's ideal because it's actually going to span some digital pins that we currently don't have a use for at the moment. So I'm going to take and put the short wire, all right, remember, look at this. The positive is the long wire. So I'm going to pay close attention to the short wire. The short wire is going to go in the ground, and if I do that, it skips 2, so that means it's going to be, here's ground, first one's ground, then it's going to be pin 0, pin 1, pin 2. So this is going to span between ground and pin 2. Okay? So now let's take and open up a little hunk of Arduino code. Move this over a bit so we can see, although it's not really important to see a buzzer. We'll do a quick test first. We're just going to make sure it works. So first thing I need to do is set pin 2 to output. Oh, mode. And we're going to pin 2 to output. Okay. And then I'll do my usual. I've already shelled out a demo 1. We're going to run demo 1. And then all we want to do is, we're going to do the exact same thing you've already done dozens of times with an LED. We're simply going to digital write it. Okay. So I'm going to digital write. And we're going to digital write pin 2. We're going to make it high. And we're going to throw in a delay. I'll make it fairly short, half a second. And then I'm going to copy these 2 lines and do a digital write low to turn it off. And actually I'm going to go for a fairly long time because it actually gets to be annoying after a little bit. So let's see what we got. We've got the pin set to output. We're going to run this function, demo 1, and demo 1 is going to oscillate pin 2 back and forth between a high and low state. So if I load this up, we should get the buzzer going on for half a second, then off for a second and a half. And to point out, let's say I didn't know which was which. I've already got this thing running, it's up and going, and I grabbed, this guy out of my toolbox, and it's like, oh, geez, I'm not really sure what this is. Let me just plug it in. Well, I can do that. I can see the positives on this side. So therefore, if I plug this in and span it across, it just clicks. I don't know if you can even hear it. Whereas if I take another one of these devices here, do the same thing, ground, pin 2, span it across. This one's actually quite a bit quieter because the sticker is still in place. And this one here, we'll do the same thing. Okay? So, that being said, let's just take well, first off, let's make it stop. I'm going to temporarily not call demo 1. Alright. Now I want to make my code just a little bit better. I'm going to go ahead and make a variable. We're going to global variable. We're going to hook it to pin 2. And it's connected. Alright. Oops. There we go. And now every place that I have a 2, I'm going to put in a buzzer. But you know all this. Okay. So I think what I'm going to do is I'm going to just create one more demo function, and we're going to call this one a day. So let me pause it, and I'll write a little function. We'll make it do something kind of cool, and I'll see you in a second. Okay, so here we've got a little demonstration, one you should be familiar with. We've done this lots of times where we've created a for loop and digital wrote something. So in this particular case, I'm going to start with the longer delay, work my way down to 0, and I'm going to pulse my buzzer. And you might expect it to sound a little bit like a siren, but this is a buzzer, so it can't really change its pitch very well. So the best we're going to get out of it is a different pulse rate. It's still kind of cool, but it would be neater to make it so that it actually sounded like a siren. But we'll have to wait to play with the passive element before we can do that. So I'm going to end this. I think you can take your buzzer, you can hook it up, you can make it go, and you'll be good to be able to use it as an indicator for any one of a number of different projects. But I will see you all again soon.